Okay, so we'll finish up 5-3 today. Still doing the same thing, just cases 4 and 5. So remember, when we're solving with elimination, 2 things have to be the same, 1 thing has to be different. 2 things that are the same are the what and the what? Letter and the number. And the thing that's different? The sign. That's the goal every time. In case 1, it's already like that for you. In cases 2 through 5, it's not. We're telling you how to fix it so that will happen if it doesn't. So we covered what happens when you have to multiply by a -1, and then we covered what happens when you have to multiply by the number in the other equation to make it opposite. That was cases 2 and 3.
Do we have to write down what case it is on the test?
On the test, no, I'm not going to ask you what case it is.
Okay.
No, you're going to see the same template, but not the case number.
All right.
So same number, same letter, different sign. So when we're solving for elimination, how does it have to be set up? We don't want y equals mx plus b. That's good for graphing. What are we looking for here? Yep.
X and y.
Yep. Right. The x, the y, and then the number on the other side separated by the equal sign. Right? So that's the same thing we're doing today. That's the order we wanted in. So, how many situations have we covered so far? 3. 1, 2, and 3. Okay. All right, so reminder. Okay. Situation 1. It's already set up. Same letter, same number, different sign. You just add the columns vertically, ready to go. Like Mr. Roy, ready to go.
Ready to go. So you, Mr. Hager.
So I'm 5 years younger than you, huh?
You're the best.
Yeah.
Yes, you are.
Does that make the numbers work out?
Yes.
Okay.
It's made it up.
Situation 2. Situation 2, not that bad. Okay, that's where you have a single positive variable in both equations. And all you have to do is multiply one of the equations by a -1. Does it matter which equation? No. Now situation 3, I told you guys how to fix that one. Okay? So situation 3, you've got a single variable, but it's only in one equation. So what to do? Multiply the equation with the single variable by the number it's attached to in the other equation. Remember, to make opposites. Alright, so that means if you had something like this, x plus 2y equals 6, -3x plus 4y equals 1. That's a case 3. You have a single variable in one equation, and you have to multiply this equation with the single variable by the number attached to the other equation to make opposites. Are the x's already opposites here? Yes, they're already opposites. So what would you have to multiply this top equation by to make them the same number? They're already opposites. You just need to get the same number. Just a 3.
Yeah. So just pay attention that there's one exception to that, like the rule of what to do for situation 3. If it's already negative, then you just multiply by the number that's attached. That's why Mr. Hager made such a big deal and emphasized to make opposites. If it's already opposite, you just have to multiply by the number. You don't need the sign.
Now, if this was the problem, and you say, well, I'm going to multiply everything by 3, then I would look at that and say, wait, 3 times x is positive 3x, 3 times x is positive 3x. They're both positive, right? You have to make opposites. So in that case, you have to make the 3 a negative. Right? So just remember, you're always trying to make opposites. All right, so situation 4. All right, so situation 4 and 5, we're not going to be able to necessarily just multiply by a number that we already see there, right? This is what we have to do. We're going to look at the number that's attached to the smaller variable, and see if it can be multiplied to give us the number attached to the same variable in the other equation.
So see if the smaller x can be multiplied by a number to make it the bigger x. Or see if the smaller y can be multiplied by a number to make it the bigger y.
So if you look at the y's here, you have a 2 in front and a 7. Can you multiply 2 by a nice number and get 7? Okay, can you multiply 2 times a number and get 7? No. I mean, you could do a decimal, but we kind of want to stay away from decimals. So when I say nice number, I mean, can you do like 2 times 3, 2 times 4 and get 7? Doesn't work. Now, look at the numbers in front of x. A 3 and a 6. Can you multiply 3 by a nice number to get 6? Yes, you can. So in this problem, that's what we're going to work with. Because you can multiply 3 by a nice number to get 6. You can't multiply 2 by a nice number to get 7. Remember, we got to get these numbers the same. That's the goal. Got to get them the same.
And guys, remember, this is when you've gone through, that's when we went through situations 1 through 3. So you've gone, doesn't fit the criteria for situation 1, doesn't fit the criteria for 2 or 3. Now you're at 4. So you're just going through, looking at situation by situation to see what situation fits your system. And you'll be able to know what to do.
Okay, so the what to do under step 4 is you're going to look at the equation with the smaller number. Okay, look at the equation with the smaller number and ask yourself, what can I multiply that number by to make it that number? That's what you want to do. What can I multiply, in this case, -3 by to make it a -6? You don't have to answer it yet, because remember, we want opposites. We don't want them to be the same. We wouldn't want to have a 6x and a 6x. We would want a 6x and a -6x. That's how they cancel out. You don't have to answer it yet. Just we'll get to it. But just copy down the what to do.
Sorry.
So you multiply everything in the equation with the smaller number by something that would make it the opposite of the larger number. That's what you're trying to do. And like Mr. Rice said, this is after you've gone through all the cases. You've checked, do I already have same number, same letter, opposite sign? Do I have case 1? Do I have case 2? Do I have case 3? Those are the easy ones. These ones a little bit harder. But what's still kind of nice about case 4 is you're still only multiplying in one equation. We haven't got to case 5 yet, which is where you're going to have to use both boxes. Okay, but case 4, you're still just using one box. People still copying down the what to do?
Yeah.
Yes.
Okay, remember on the test, it's kind of a giveaway which if it's going to be a case 1 when you look at the template. How do you know looking at the template if it's automatically a case 1? There's what? Well, yeah, that's what you look for, but what about the template itself? Like the thing that we fill in. It's not going to have the boxes. So if you see the boxes on the template we give you, then you know it is case 2, 3, 4, or 5. It's not a case 1. Okay, so as I said earlier, the test is 7 questions. It's got one of every case. I think there's 2 of one of the cases, and then the last question is a word problem, which we'll do one today like it. All right, so we've gone through it. Same letter, same number, different sign. No single positive variable in both equations. No single positive variable in one equation. No, everything's got a number in front of it. So now let's get to case 4. Number attached to the smaller variable. Can we multiply it to get the bigger one? So we check the y's. Does 2 times anything give me 7? Then forget about the y's. We're not going to deal with those right now. Can I do 3 times something to get 6? Yes. So the goal here is to make those 2 numbers I circled opposites. All right? So let's check if they're lined up. But we know it's a case 4. Is everything lined up the way we want? Yes. We've got the x's, the y's, and the number. So if they're lined up, where do I put them? Yeah.
I just have a question. Is the multiply top or bottom to eliminate going to be on the test too?
Is that in the template? It's not going to be something I grade, so it's there for you if you want to help you.
It's there. It's on the template, but it's not something that where you're not required to fill in.
Is it going to be on the test? Like, is this going to be on the test?
The template will be on the test, just like that.
Okay.
So for situations 2 through 5, we have that same exact template on the test.
Okay.
But again, we're not going to take points off if you don't identify and multiply the top of the bottom.
So that could help you out in figuring out.
Exactly. Yeah. Yeah. That's what we'll say. If you, like Mr. Hager was just saying, if you can have a template like this, then it's going to be a situation 2 through 5. All right.
So which equation am I going to multiply by here? Top, or am I going to multiply the bottom? Which one? Yeah, we're going to multiply the bottom. You don't have to tell me by what yet, but what letters or what letters are we going to work with? Because we can make the numbers in front of them opposites. We're working with the what? Yeah, we're going to try to eliminate the x's. So we're not going to multiply the top equation. We want to multiply the bottom equation by a number to make this and this opposites. Does anybody see what number you could multiply the bottom equation by? And that would happen.
2.
2. Yes. Perfect.
Because you already have the negative there. It's already a -3, so you don't need to multiply by a negative because it's already there. It's already part of it.
So top equation, we're not doing anything to it. We're just going to copy it over. From here, this is exactly like a case 2 or 3 problem. We just do all the same work, same template. 6x minus 2y equals 8. Now in the bottom, remember to double or multiply everything by 2. Everything. Don't forget the 4. Some people forget the 4. So Nate, what's 2 times -3x? Yep, -6x. Dave, what's 2 times -7y?
-14y.
-14y. Right, and Paige, 2 times 4? 8. Okay. Now we just wrote it down. We're going to be eliminating x's. 6x, which is a positive, -6x. That's a negative. Gone. Add everything else that's left. Savannah, what's -2y and -14y? -16y. And Jake, if I add 8, what's up?
Mr. Hager, Chris has brought up a point. That top equation, it equals -8, not 8.
Oh, -8. Okay.
Which means that that would be negative.
So that one would be negative. Yes, thank you. So we didn't,
Wow.
luckily, we didn't multiply the top equation, so it didn't mess us up yet, but it would have messed us up right with what I'm about to write. So all you got to do is add the 2 negatives and we're still okay. -8 plus 8. What's that? 0. So get 0. And now last step in this kind of equation is to always
Divide.
by
-16.
-16.
And guys, that middle box, what you're doing there what you're trying to get there never changes. You're always gonna multiply there.
So what's 0 divided by -16?
0.
Yep, 0. So that's going to be nice because when we plug that back in, the arithmetic's easy. Right? Which one should we plug back into? Yeah, we could do equation 1. I'm going to fill that in. So what's going to happen when you do negative 2 times 0? It's gone. So all we're going to have left is 6x minus 2 times 0, which is gone, equals negative 8. So 6x equals negative 8. All right, last step. By, yep, by 6, and negative 8 divided by 6, you can just reduce that to what fraction? Close.
1/2.
No, closer with what Donovan said.
3/4.
Can you say what you said again?
Negative 4/3.
-4/3. Yeah. So if you get that far and then you forget the negative, that whole answer is going to be wrong. Okay. You could still get credit for the other answer. You could still get credit for the equations you did right, but you'd lose all the credit for that answer. Okay. So again, reminder on the test, what I'm going to look for. Did you get equation 1? Did you get equation 2? Did you get y? Did you get x? 4 things. Questions on that? All right, so do we want to do 1b?
Yeah.
Because we got 2 after this, right?
Yeah, so we got a situation 5 and then a,
All right.
5.
Yeah, I think what we'll do, guys, let's do situation 5.
So you have one example of each.
And then you'll have an example of a 4, a 5, and a word problem. And if we have time at the end, we'll come back and do 4.
All right, so situation 5, all right? In terms of what you're looking for, it's not gonna be as much to write as we did the last time. So if I go over, right? So what I'm looking for is none of the above. It doesn't fit any of the situation, any of the criteria of what you were looking for in situations 1 through 4. So no same number, same letter, different sign, no single variable in both, no single variable in one, and then there's not a variable that can be a smaller variable that can be multiplied to get the bigger variable. So situation 5. So you've looked at the problem, you've gone through situation by situation. None of the things are there. So now you're at a situation 5. All right? So it's a little wordy, but it's, again, when we show the example, it will make sense. So you're going to choose the smaller set of numbers attached to one of the variables, x or y. All right? You're either going to choose the x's or the y's. Which numbers are smaller? Are the numbers with the x's smaller? Are the numbers with the y's smaller? It all depends. And you're going to multiply each equation by the number attached to the variable you chose in the other equation. So let's say, like for this one, right? I have 4 and 5. I have -3 and -2. -3 and -2 are smaller than 4 and 5. So if it were me, I would choose the pair of numbers. I would choose to eliminate y. If you choose to eliminate x, you're not wrong. Just when you multiply, your numbers are going to be a little bit bigger. All right? That's why I'm saying, Mr. Hager, and my suggestion would be to choose the smaller pair. And then use the opposite sign if necessary. One thing I want to add that's not on there, never mind. So, really important thing, we're multiplying each equation. So this is the only situation where we have to multiply in both. First situation, we don't have to multiply in either one. Then situations 2 through 4, we have to multiply in one equation. Situation 5, we have to multiply in both. The top equation and the bottom equation. So this is the only situation where we have to do that. We have to multiply them both. So we'll choose the smallest set of numbers attached to one of the variables. Again, see which pair is smaller. If you don't pick the right pair, that's okay. You're still going to get the same answer. And like I said, I underlined, you're going to multiply each equation by the number attached to the variable you chose in the other equation. That may seem kind of, what does that mean? When we go through this one, it'll make sense. All right? So all you're really going to do is look at the, okay, we're going to eliminate x, right? So look at the x in the other equation, multiply the top one by that. Go to the bottom one. Look at what's attached to x in the top equation, multiply the bottom equation by that. All right, it's that simple. All right, everybody good with copying this down? Everybody's good? All right, so here's our first example. First thing we have to ask ourselves is what? I don't care if it's situation 1 or situation 5. What's the most important thing, Brady? We gotta make sure what? We gotta make sure that before we can do anything, what do we have to make sure of?
Oh, that it's lined up.
Is it lined up?
Yeah.
Yeah. X is over x, y over y equal, and then a number at the end. So we're lined up. So what does that mean?
You don't have to switch it around.
Yeah. So what can I do now, Donovan? I can just take it and write it in the boxes, right? I do all my rearranging outside the boxes. Once I plug it in the first box, it's all set to go. I'm ready to multiply, do whatever I need to do. 4x minus 3y equals 8. 5x minus 2y equals negative 11. All right. So just to show you one more time how the situations work. Situation 1, same, we know it's situation 5. I wouldn't give you an example. We're talking about situation 5. I wouldn't give you a situation 3 to do right now. So, situation 1, same number, same letter, different sign. I got a 4 and a 5, they're not the same number. I got a negative 3 and negative 2, not the same number. It's not situation 1. Single variable, single positive variable in both equations. I got numbers attached to both the variables in both equations. It can't be that. Situation 3, it can't be that either. That means I want a single variable in one of the equations. Like I just said, there's numbers attached to all the variables. Situation 4, does one of the smaller ones can be multiplied by a number to give you a bigger one. Can I multiply 4 by something to give me 5? No. Because 4 times 1 is 4, 4 times 2 is 8. I'm past 5. Can I multiply 2 by something to give me 3? No. 2 times 1 is 2. 2 times 2 is 4. I'm above 3. It doesn't work. So I'm at situation 5. So it said to choose the smaller pair of numbers. So are the numbers with the x's smaller or are the numbers with the y's smaller? The y's, right? So I got negative 3 and negative 2. So I'm gonna multiply the top and the bottom. If I've identified the y's, what am I eliminating? No, if I've identified the y's, what am I eliminating? The y's. Okay. So I'm going to scroll back up a little bit. If I scroll back up a little bit.
You can click the double arrow. Yeah, put it there.
There we go. Alright, so it says multiply each equation by the number attached to it to the variable you chose in the other equation. So I'm looking at the y's, right? Top equation, right? It says look at the number, I'm eliminating y, look at the number attached to y in the other equation. So in the other equation, I'm looking at the top one now, but if I was basing it, what's attached to y in the other equation? If I'm looking at the top one, right? What's attached to y in the other equation?
Negative 2.
Negative 2. All right. Now when I do negative 2 times negative 3, it'll give me what?
6.
Positive 6. Keep that in mind, because we want to end up with opposites, right? Ellie?
For the bottom one, would you do negative 3?
I like 3,
Okay, just 3.
not negative 3. Why wouldn't I multiply by negative 3? Somebody tell me. Nicole?
2 negative 2 plus
Yeah, if I multiply this by negative 3, I get a positive 6. So I have positive 6 and positive 6. Why would that be wrong, Mary?
Because then it wouldn't cancel.
It wouldn't cancel. Again, what are we trying to get, Mary?
Like the one variable to cancel out.
Yeah, we want opposites, right?
Could you multiply either one by the negative? Does it matter?
It doesn't matter. Like Mary's saying, can I do multiply by negative 3 down here and then positive 2 up here? Absolutely. As long as they come out to be opposites. I mean, you could have picked the y's too. You could have picked the x's too. What could I have multiplied the top equation by to eliminate x? Can somebody tell me? Well, if I chose the x's instead, what could I multiply the top equation by to eliminate x? Gigi?
0.
If I wanted to eliminate x instead of y, what can I multiply the top equation by? 5, right? Someone tell me what can I multiply the bottom, Savannah, what can I multiply the bottom equation by to eliminate x? Negative 4. I got a 5, I got a negative 4. We're going to multiply by what's attached to the number in the opposite equation. Donovan?
Why do you multiply by negative?
Good question. If I was going to eliminate the x's, they're both positive. So I have to multiply one by a negative to make it opposite.
But what if one is a negative and one's positive?
If one's a negative, one's a positive? Exactly.
Okay.
Then you can multiply by a positive. The only time we're going to have to multiply one by a negative and one by a positive is if the signs are the same, we have to multiply one by a positive, one by a negative. Here, they're both positive, then I have to multiply one by a negative one. I don't care which, like Mary just asked, I don't care which one you use, doesn't matter. So, so you might want to add that just to that situation if you have room. If, like we had here, if the signs are the same. So if I want to eliminate the x's, they're both positive, I gotta multiply one by a positive, one by a negative. Same thing like we did with the y's. They're both negative, I multiplied one by negative 2, and then the other one by positive 3. So if the signs attached to the variable you want to eliminate are the same, then you've got to make sure you do one by positive, one by negative. Alright? Like Donovan said, if one's already positive, one's already negative, you can multiply them both by a positive. It'll work out. Because remember, we're trying to get opposites. Alright? So that top equation, right? I'm going to multiply by negative 2. What's my first term going to be? What's it going to be? Negative 8x. Good, Nicole. How about Natasha? What's my second term going to be? So I did negative 2 times positive 4x. I got negative 8x. I want to multiply negative 2 by negative 3y next. When I do that, what do I get? I'm doing a negative times a negative. Positive 6. Anything else? Y. Bring my equal sign over. Remember, Mr. Hager and I have said all week, you have to multiply the number after the equal sign as well. What's my last term going to be? Someone tell me. What's my last term going to be? Nicole? Negative 16. Very good. Negative times a positive is a negative. Again, don't try to do all your multiplying. Don't try to do your multiplying before and put it in this box. It won't work out. Make sure. I don't care if it's situation 1 or situation 5. Make sure everything's lined up in this box first. Then if you see the 2 little boxes, you're going to have to multiply. Most times you have to multiply in one equation, but in this case it's a situation 5, so multiply in both. All right? Bethany, what's my first term going to be in my bottom equation, or equation number 2? Multiplying 3 times 5x. What do I get? 15x. Perfect. How about Garrett? What's my next term gonna be?
-6y.
-6y, very good, so we wanna eliminate. And then, Maddie, what's my last term gonna be? -33, very good. So now I've done all, again, I don't care what type of situation it is, you're always gonna solve for the first variable. You're always gonna solve for your first variable in that middle box, all right? So here, we got, I'm gonna work backwards. So I always wanna keep the sign in a larger number. So 15 minus 8, because 8 minus 15 sounds kind of weird in your mind. I'm gonna go with the bigger positive number first. 15 minus 8 is gonna be what? 7x. I should have said x too. What about my y's? That's why I multiplied by -2 and +3, so they would eliminate. My last part, both signs are the same, but I'm not multiplying and dividing. So what happens?
Add.
Add? What happens to the sign? Do I get rid of it?
Stays the same.
I keep it, right? Keep the sign, and like a bunch of people just said, add the numbers. 6 plus 3 is 9. 1 plus 3 is 4. Keep the sign, add the numbers. One more step. What's it gonna be?
Divide by 7.
Divide by 7. What's it gonna be, Donovan? X equals what?
-7.
Nice job. X equals -7. Again, if it's situation 1 or situation 5, it doesn't matter. We do the same thing in that last box, right? What are we gonna do? What do I do now? It's been the same all week. Yusuf.
Plug in -7 for x.
Okay, which equation do you want to use?
I guess the first one.
Let me use the top one, so tell me what to write.
So 4
Yeah,
parentheses -7.
perfect.
Minus 3y equals 8.
Nice. Very good. Dylan, what am I gonna do first? Allie,
Multiply plug 4 by -7.
you know what that is?
Distribute.
I can distribute the 4 into the -7. My answer gonna be positive or negative? I'm doing a positive times a negative.
Negative?
Negative. Yusuf, say what you said.
-28.
Nice job. Everything else is coming down. Again, the steps here are always going to be the same as well. You're going to multiply, move the number that's with the variable, and then divide, right? Move the number that's on the same side with the variable, right? So in this case, what's the number that's on the same side with the variable? Ellie?
No.
Not the number attached to the variable, the number that, basically move the other number.
So -28
-28, so how do I move that?
plus negative.
Plus 28, it's plus 28. Okay. Bring down my -3y, then I'm gonna get 36. Then divide by what number? -3. What's my answer? Y equals -12. Now, last thing for this one. What would if this is a multiple choice, what would the answer look like? Ellie?
-7, comma, -12.
-7, comma, -12. All right? That's how. Now, if it were me, if it's a multiple choice question, whatever variable I solve for first, whether it be x or y, I would look at my choices. And I would say, okay, whatever ones don't have -7 as the first number in the pair, I cross it out. Or if only one of the choices has -7 as the first term, pick that one. That way you don't have to do all the work for the other one. It'll save yourself a little work. But if there's 2 of them that have -7 as the first term, then you have to do it. Right, so this is a little helpful. Right? So that's situation 5. That's as hard as it gets, because you have to multiply them both. All right? One more thing. Word problem. Right? But you're gonna see the word problem's not gonna be too bad.
It's never like a case 4 or 5.
Yeah, and usually not even a case like 2 or 3. Usually we try to make it pretty simple. Alright? So let's look at the word problem. So, this, guys, for the case, this to be consistent. Now, guys, this doesn't really work for our ages. I just made it up. But I just used Mr. Hager in my name. That's all. Now, the one tomorrow, actually the one on the homework tonight, that's based on my dad and my uncle. So the last one, the homework tonight, is based on my dad and my uncle. This one, I made it up quick. This isn't, because Mr. Hager, if I gave you like the one from Mr. Hager and I, then
Be 100.
it wouldn't be 100. It would be what? 171? All right.
Our ages, yeah.
Yeah. Some of our ages would be 71. Mr. Hager is I'm exactly 1 year older than Mr. Hager. Exactly 1 year, to the day. We're born on the same day a year later.
Really?
Yeah.
So you guys' birthdays are the same day?
Yeah, I'm born on November 1st, 1982. He's November 1st, 1983.
Wow.
And like we co-taught, I think it took us up like, I think we co-taught for like 3 or 4 years together before we even realized that. And we had the same birthday. So we're exact. So so ours is pretty simple. It's only 1 year difference. That's why I kind of just made this one up.
That's kind
Alright,
of cool.
so for the case, guys, to be consistent, we're gonna use Brent. We're gonna make Brent X, and we're gonna make Tim Y. That way, it's consistent with everything we've done this week. We've always used X and Y. All right. So Brent. So Brent is what? X, right? So we're gonna put X. What does is mean? What sign does is translate to? Ellie?
Equal.
Nice. Equals. So is equal.
Where should we write this down?
Example 2B. We don't have it.
In the last 2 weeks.
Example 2b.
Oh.
Yeah. So guys, this is example 2b. So I'll give you a second to write down the actual problem. All right. So Brenda's 5 years older than Tim. The sum of their ages is 53. Find the age of each. All right. So I'll give you a second to write that down.
Doesn't like Dan mean subtract?
you actually do a problem now?
Yes, please. So I can give you guys on the reference sheet, if you wanna write this word problem down, if you wanna use this one, or the one from the homework tonight, and put it somewhere on your reference sheet, you can. If you wanna put different examples of the different situations, right, you gotta have all the steps to be able to do it, but if you wanna put an actual example so you can see it happening, you can do that too. Or if you don't want to fill the reference sheet out at all, I don't recommend it, but you can do
Good
it.
luck to you.
That's your choice. You're not going to lose any points. But don't expect, if you don't have anything like filled out tomorrow, don't expect Mr. Hager to answer any of your questions during the test. Because you didn't really prepare. Alright? So Brennan's 5 years older than Tim. The sum of their ages is 53. Find the age of each. So the first sentence is going to be the first equation. The second sentence is going to be equation number 2, and then the last sentence is just telling us what we have to do, right? So 5 years older than Tim. So for the case of this, I'm going to put y first. I want to put the variable first. That is a bold move. Thank you. All right, 5 years older. How would I express that? 5 years older. Ellie?
Would it be like
Plus 5.
Right, Chris. Plus 5, right? To get to Brent's age, right? From Tim's age to Brent's age, you have to add 5. 5 years older, so you're going up in age. The age is increasing, so you're going to add 5. If it was younger, you'd be subtracting, but here it's older. So this is equation number 1. Now, the sum of their ages. Sum means what math operation? addition. So I know I'm going to need a plus sign. What does is mean again? Ellie already told us what's it mean? Equals. I'm going to leave a little space, put an equal sign. Equals what number? 53. What's going to go on either side of the plus sign? Joe? X and Y. Because Brent, right now, all we know about Brent is X. There's no number to express him now. Because we have to solve it. We have to set it up and solve it to figure it out. So all we know about Brent is we decided, or I decided, that we're going to call him X. And all we know about Tim is he's Y. That shows the sum of their ages. Brent is X, Tim is Y, sum is add, is equal 53, because it told us. There's our two equations. Now, you'll get the chart tomorrow to do this. All right? Now, are we all set to go ahead and write it in?
No,
No. Why do you say no, Donovan?
because they don't match the equation.
Which one doesn't match?
The top one.
Top one. So at the bottom one, I can write in x plus y equals 53. Donovan, do you know what to do to get the top one to be lined up?
Could you subtract 5?
No, because I want the number.
Oh, wait.
Okay.
You would.
You're on the right side. You're good.
You'd subtract the y.
Subtract the y, right? So my new equation, well, it's not new, but my equation lined up correctly is going to be what?
Negative 1y. Or you can negative
What should be first, though?
x.
X
Negative y
minus y
equals 5.
equals 5. There it is. Now, the template is not really the template doesn't really match this type of problem. Why? Anybody know? Why doesn't this template fit this problem? Joe?
Because it's situation one.
Yeah, it's situation 1. Why, Joe? Tell me.
The X's and Y's are
Okay. So are the x's opposite?
they're alone.
They're alone, but are they opposite?
The Y's.
The y's are, yes. Right? So we got same number. There's a 1 attached, even though you don't see it. Same letter, they're both y's, and they're both, one's positive and one's negative. That's all set. All right? So I don't have to, I think tomorrow, guys, on the test, I don't think you'll have this template. I think it'll be the other one. All right? So I'm just going to do some work under here, right? I don't need this because I'm not multiplying. So Joe, this first step, right? What am I going to do?
Eliminate
Eliminate what letter?
the Y's.
The y's. The y's are going to cross out. Okay? And I'm going to get, what else is left?
The X.
How many x's? 2x equals 58. Remember, this one's, when it's situation 1, it's a little different. You're going to do your addition vertically in the first box. In situations 2 through 5, you have to multiply everything, get it in the middle, and then you'll simplify. You would multiply, add it vertically and then simplify. All right, but with the situation 1, we're going to take what's here and we're going to write it in the middle. All right, what am I going to do now? Good, Nicole. Divide by 2. X equals 29. How about Easley's? What do I do now?
What?
What do I do now?
You're talking to me?
When I get that, that's a couple of years ago. Wow. That's like 2 years ago. Wow. That was a girl we had a couple of years ago. I don't know why that is. I said it. Like, what am I talking about?
Boy.
We had her 2 years ago, right? Oh my God. The jelly, I'm sorry. Have to meet me sometime. What am I gonna do now? Wow, that's wild. What do I do now? So I got what x equals. What am I gonna do now? Top one or the bottom one? You could use the top one. Me personally, I would use the bottom one because everything is positive. The top one has a negative y, and I'll show you in a second. So I'm gonna do the bottom one. So so x is gonna be what now? 29. What's next? I'm doing the bottom one. Plus y equals 53. What do I do now? Subtract one number. Minus 29, minus 29, y equals, it'll be, let's see, 4, this will be 4, 24. Am I right, Mr. Did I do that right?
Yeah.
24, okay. So y equals 24. Now, you could still do, you don't have to write this, you could do the top one. 29 minus y equals 5. You're going to minus 29, minus 29. You're going to get negative y equals negative 24. Then you have to divide by a negative 1. Y equals 24. So you're not wrong picking the top one, but just it's a little more work. You're dealing with negatives. So you're going to know 25 minus 29 is negative 24. Then you have to remember to divide by negative 1. All right, hold on, listen. So homework, test review. All right, that's the homework. The reference sheet is not. It's all up to you how much of the reference sheet you want to fill out. I'd fill out the whole thing.
I agree with you.
Like I just said, it's on Google Classroom. It's all the situations on one sheet. If you want to put different examples, you can. If you want to write the word problem example, you can. It's entirely up to you. Mr. Hager and I are both after school today. I'll be after till 3:30 down in my room across from Cosmo, 225. Again, we had this conversation on Tuesday. Don't wait till it's too late. Summer school's real. I'll have my mowers on the back of the truck. I'll have my nice iced tea from Dunkin'. How you doing? I'm making money. You're in summer school. The air conditioning's okay here. It doesn't work great though. You don't want to be here. And then, guys, tomorrow at 9th period, you get your progress reports.
That's your motto.
What? Summer school's real.
Don't wait till it's too late.
Summer school is real.